Hello, my name is Gregory Daniel Ziegler, and today I'm going to show you the Mitnick attack with my work with my team, Christina Sandri and Mani Gupta on COASA 330 with Professor Mohammed Gabriel. This is for a lab demo for the final project, 330 project. It's due on Thursday, December 10th. This is our final project. It's a lab demonstration that I'm going to show how to do this lab and hopefully get it to work. But first, I'm going to discuss you kind of the background of this attack. So this is it's called the Mitnick attack. A man named Kevin Mitnick did a early kind of hijacking attack back in the early 90s, where he was able to intercept the TCP protocol, Chain of Control Protocol, back in the early 90s, because he was researching cell phone security, cell phone networks, and he was in need of some specialized software to hack cell phone networks. So which led to him to Tsutomu Shimomura. Again, I'm butchering his Japanese, but this Japanese fellow who was working at San Diego Supercomputer Center and was one of the leading researchers on cell phone security at the time. Again, this is back in the early 90s, mid 90s, where cell phone security, I think it existed. I wouldn't say cell phones are very secure in the mid 90s. This might have been either 1 or 2G. I don't think 3G came out. I mean, 3G came eventually, I think around the year 2000. So this is probably back when 2G existed. And there was some security of 2G. It wasn't great. Probably better than nothing compared to 1G where everything was not encrypted, not secure in the 80s. And in the mid 1994, mid 90s, that's when cell phones became more mainstream. Before the 90s, like in the 1980s, you had cell phones, but they're really only reserved for like millionaires and business people. There's a scene in Wall Street, 80s movie, with Michael Douglas and Charlie Sheen. And there's a scene where Michael Douglas is calling Charlie Sheen through a brick cell phone. During the movie was filmed in 1987, so about that time, which is a big brick cell phone, and the only people who could buy and use cell phones were millionaires. No one really had the average person didn't really have a cell phone until like the mid late 90s. I remember, and for me, my mom didn't get a cell phone until I think about when I was born, which was probably 1997. And even in the late 90s, not everyone had cell phones. It wasn't until like the 2000s everybody had a cell phone. But it was actually quite famous back when Kevin Mitnick did this. He actually on the FBI's most wanted list in 1994 because of it. Because the TCP protocol wasn't hacked before. This attack where you had to intercept a trusted protocol, which people thought, there wasn't any problems with these protocols. At least the average person understand there was problems with it. But Kevin Mitnick showed the vulnerability to it, through spoofing packets and whatnot, that you could intercept this trusted relationship between computers in the three-way handshake, the TCP three-way handshake, which made him very dangerous because this was like a zero-day vulnerability. No one really knew this. You could do this, but Kevin Mitnick was really smart. He was able to figure it out how to hack Shimomura's computer. So next, I'm going to show you how it works. So how it works was you had Shimomura. He had a rhost file on his computer. The rhost file was able to remote into his computer. Again, this was RSH, remote shell, which should not be confused with secure shell, SSH. Remote shell was plain text, not secured. SSH came later, maybe in part because this happened. SSH, RSH, anything was plain text. You sent data through plain text. It was transmitted to plain text. Nothing was encrypted. Nothing was secure. But it was Shimomura's, belief that it would only be him accessing his own computer at his work in San Diego. He didn't expect someone else to intercept this. It will intercept TCP protocol to access his computer. So Kevin Mitnick wanted to access Shimomura's computer, the victim machine. So what he would do is that he would have his trusted server. He would use SYN packets and flood the trusted server. Eventually, trusted server would shut down due to denial of service attack. So this server would no longer be on. And then Shimomura, kind of a weakness here, he allowed remote access without a password. So literally, he just had the RSH, the IP address of this computer, his computer, it would be in. Problem is, you need that R host file to do that, which he had. But Kevin Mitnick was able to access the R host file through hijacking the TCP protocol. Session hijacking attack. So how Kevin Mitnick did this was he had sequence number prediction. So back when he did it, sequence numbers were in numeric order. Nowadays, this would mitigate, guessing the sequence numbers. Now, sequence numbers are randomized. But back when Kevin Mitnick did it, it was all like, 1, 2, packets 1, packets 2, can't packet 1, packet 3, can't packet 2, so on and so forth. So he was able to, just add numbers, plus 1 to the number to make the protocol work. So then you had SYN-ACK responses. So he was able to sequence number predict based on, doing SYN requests and predict the numbers. So then he SYN flooded the trusted server. So he keeps sending requests to the trusted server. He wanted to take the server down because he wanted to spoof his computer as the server. So he shut the server down by flooding it, and he wanted his computer to seem like it was a server, according to Shimomura's computer. And then now he spoofed the TCP connection, which he spoofed it, and this is when he tried to throw a handshake between these two computers, with this computer pretending it's the server. Because the victim and the server already have a trusted relationship, so he wants to impersonate the trusted server to pretend he is the server, to exploit the trusted relationship between Shimomura's victim machine and the trusted server. And it says here you need R host file. The R host file was for Shimomura to access remotely to his computer. You need the R host file to do that, to remote in. And then after he intercepted the TCP connection, he did a SYN-ACK connection, and he was able to exploit it based on the 2 connections he made. He was able to command in and to Shimomura's computer. And once he did that, he RSH'd in, did echo ++ to the host file, and when he does that, the ++ means you have no username, no password. You just automatically log in. So, in order to do this lab, you must do the RSH program. So again, RSH has been discontinued in part because RSH is insecure in plain text. It's not SSH. So it's been discontinued. So you need to do a legacy software. And there's a thing called RSH Redone Client, which lets you install the old version of RSH, the unsecure version, in order for this to work. So fill these commands. Then you got to make the R host file on the victim machine in order to remote in. And then in order for it to work, you should be able to, from the server, you should be able to RSH in for the date. And when you RSH for the date, it will pop up the date of the machine. Then next you do RSH. So then it explains the plus plus. So the plus plus means anyone access the server through the rhost file. So then now let's do task 1, which is simulate the SYN flooding attack. So for the SYN flooding attack, what you want to do, just give me one moment here. Sorry about that. So I was running a quick command here, make sure it worked. So you've RSH the IP address of the victim of the date. You get that as Tuesday, December 8th, 8:41. So this should be the correct time. So you get the correct time date. And if this works, you set up the rhost file correctly. And here I'm just going to run this command. So you have rhost, able to remote in, is the configuration for it to work. So now it should work based on the configuration page. So I'll show you this is the first step, and then here is the second step. So if this works, you should be able to get today's date, which is, and if these, if you get today's date, you set up the RSH correctly. So the first task here is a simulated SYN flooding attack, which Mitnick did to shut down the X terminal server. So to simulate that, we're going to disconnect. This needs information for the ARP table. And then we're going to pretend this is shut down. So we press disconnect, right click, disconnect. So I'm just going to say right click, disconnect it. So now we're saying the server is shut down. Because when Kevin Mitnick did it, he shut down the server. And then we'll go to the victim machine, terminal here, and we're going to do sudo arp s, the server's IP address, which is, and then its MAC address. Okay, so then now it's in the ARP table. This is just able to simplify the attack because now it has the route or ARP route to connect to the server. It has ARP connection. Now back to PDF here. So first task here, task 2, is you want to spoof the TCP and RSH connections. So I kind of use this as an example here, is that this is how the connection should work. You have the source IP, destination IP, the TCP port headers. Then you make it a SYN sequence number. And then you get the acknowledge number when you reply. And this should be how exactly it should work to initiate both connections. You have to use a program called SCAPI to send the TCP IP packets that you spoof in order for this to work. And so I'm just going to say here, this is for acknowledgement. So, and to simulate the original Mitnick attack, you should only use the sequence number, the flag field, and lengths field. Wireshark will give you more information, which will make it easier to spoof. But in order to give you an environment that's similar to what Mitnick had back in 1994, the other values you shouldn't use. You may use them. There might be a point deduction if you use them based on whatever professor does the lab. But in order to simulate how Kevin Mitnick did this in the mid-90s as much as possible, you should only use these values here. So first, let's go ahead and simulate the first connection. So I'm going to spoof the IP address, and the sequence number is this. Packet IP TCP is this. And I'm going to spoof that connection. And I'm going to run Wireshark. So now I'm running Wireshark. So then now, my first is to run the spoof attack. Okay, so my TCP packet went in. So then now, so see the SYN attack. Now I get acknowledgement. So this was only a SYN packet I sent. And then now I get a reply saying it's a SYN acknowledgement packet. So I got a reply from the victim machine. So it meant that this TCP connection went through. So that's my first step. So then now I want to run this attack code, which should be able to work. Which I want to respond with, right here. I want to respond so I respond with an ACK packet. So I'm going to Wireshark and just give me a second here. I'm going to go back, make sure I got these numbers correct. So then you respond with a sequence. So it'll be this acknowledgement number, so that'll be sequence number, then your acknowledgement will be sequence plus 1. So let's go back to here. So the sequence is that. So our acknowledgement is going to be sequence two two four. Make sure I do this correctly here. Just make sure I get this correctly here. Sequence number okay, so this should now work. So now the Mitnick attack should now work. Now okay. So now based on successful, I was able to establish start RSH session based on 2.4, 2.5. So I was able to get the first connection to work. See, it says the RSH session establishment. Based on those two numbers I calculated, I was able to establish RSH session. So the first connection worked. So then now that worked. So then now I have to do and as you can tell from the acknowledgement, just kind of combine both steps here. I have the data, which is C, des, and I'm going to create an XYZ folder in the temp file, which I think this RSH has the data. Yep. So the RSH are kind of combine steps here to one and one. Then now with the data, you see that I have my command to port 9090. C is your name, des is the password, touch, which is to make a file and temp called XYZ. So then now I have to spoof the second TCP connection. So I need to initiate a second connection for this to work. Then now I have to do a SYNAC number, which I go here right. Which will be the +1 sequence number. So now here. So a sequence number is this. So I'm going to add that to +1. For 1, item 1, 421, 422. Coordinates diagram, I'm going to add +1 to it. Now, this will work. So Synac, and then now we have RST. So now the RST should work. So then now I establish both connections. So I got my second RST. So then now I was able to have established that connection. And now the RST session is now established. You see here the Synac and then the RST. So got the RST response, which means my Synac packet did work. So then now I have to check to see if everything worked. I'm going to go to my victim machine and on the terminal here, I'm going to go to temp, and then you see here XYZ has been made in the payload. So XYZ has now been used as the payload. Therefore, XYZ now works. So then now, for this, what we want to do is create the backdoor. So now with RST connection, we're able to make it. So then now we're going to make the backdoor. So, for this to work, I'm going to go back here. And I'm going to go back to the acknowledgement. And instead of doing creating the folder to make sure it worked, now we're going to do the backdoor part of this. So now that should work. Echo plus plus, that's our host. So now let's do the acknowledgement. Okay, so it should go in hopefully. So RScan, how it was able to work, went through, here's the data, went through. So then now, all we have to do here, through a new terminal, all I got to do is RSH through the victim's IP address. And there you have it. It worked. So it would automatically log in based on the commands. So this was Kevin Mitnick, and how he was able to do this attack. Was basically exploiting, and here's kind of RSH, rlogin, TCP. So he was able to hijack the TCP protocol established with information here. And you can tell my my Wireshark was able to work for the TCP packets I sent through Scapy. And it was able to work with the attack. So that's Kevin Mitnick, the Mitnick Attack Lab. I hope you enjoyed this video. Point some here. And let me know any questions or concerns. Thank you so much. Bye-bye. Again, this is Gregory Daniel Ziegler, Christina Sanji, and Manik Gupta. Thank you so much. Have a good day. Bye-bye. COSC 330, Monica Bro. Thank you. Bye-bye.